First of all, what is a rational number? A rational number is the ratio of two integers. For example, the fractions 1/2, 3/2, and even the whole number 2, these are all rational numbers. The number 2 is a rational number because it can be written in the form of 2/1. Terminating decimals are also rational. For example, 1.5 can be written in the form of 3/2, just as 1.3 can be written in the form of 13/10. So therefore, terminating decimals also represent rational numbers. Repeating decimals are also rational numbers. For example, the number 0.3 repeating, or 0.3333, and so on, is the same thing as 1/3, which again is the ratio of two integers. So let's do some rational number review. 4 basic things can be rational numbers. Integers, such as 1, 5, 7. Common fractions, such as 2/3, 4/5. Terminating decimals, such as 1.2, 6.5. And then also repeating decimals, 0.3 repeating, 0.5 repeating. These are all examples of rational numbers. Let's move on to irrational numbers. What is an irrational number? Irrational numbers are numbers that are not rational. Let's look at some examples. Our first example of an irrational number is pi. Pi is an irrational number because it is non-repeating and non-terminating. Another example of an irrational number would be the square root of 3. Any square root in which the number is not a perfect square is going to result in an irrational number. If the number under the radical is a perfect square, such as the number 4 or 9 or 16, then the number is going to be rational. In the example of 4, the square root of 4 would be 2, and we know that the number 2 is a rational number. Another type of irrational number would be the product of an integer and any other irrational number. The examples here, 3 radical 2 and 4 pi. We know that radical 2 is irrational, so therefore that is going to make the number irrational. We also know that pi is irrational, so therefore 4 pi would also be an irrational number. Let's review the irrational numbers. 3 basic types. First of all, pi is irrational. We also know that any non-repeating, non-terminating decimal is also irrational. And lastly, anytime we have the product of an integer and an irrational number, that is also going to give us an irrational number. Let's look at some practice problems to see if you understand. Let's start with 35.72 repeating. Is this number rational or irrational? Hopefully you said that this number is rational. Anytime we have a repeating decimal, it is a rational number. How about the number 5 pi? Rational or irrational? Hopefully you said that 5 pi was irrational. How about the square root of 40? Rational or irrational? Hopefully you said the square root of 40 is an irrational number. The reason is the square root of 40 gives us a decimal that is non-repeating and non-terminating. Lastly, how about the square root of 64? Rational or irrational? Hopefully you said for the square root of 64 that it was a rational number. We know that the square root of 64 is 8. We know 8 is an integer, so therefore it is rational. This concludes our video on rational or irrational numbers. Hopefully you better understand this concept and can again accomplish another pie piece as you move through your journey with Alex.